We're going to see how this goes. It's been a while, but I realized from last time that pretty much the other computer algebra systems that I was doing are just the wrong way to do things, and that the symbolic approach is correct. So I've basically made a minimal Wolfram kernel that allows me to do basic stuff. Right now there's some notable missing things, and there's tons of features that I have no plan to implement. But if I just do this, I guess the first thing to do is it's not an M expression as Mathematica does it, but it's S expressions just because the parser is so simple. You can look at the parser. This whole thing's like 500 lines of code, but it's basically just just this 10, 5, whatever rules or so. Here, my numerics is pretty much just not thought out at all. I don't really care about that because I'm not going to do numerics right now. So, like, for instance, I don't even have 1 plus 1 in my language. But I will say, this thing bit me yesterday. It's crazy. It's actually like a big bump. It wasn't a mosquito. It was like some weird thing. This is the expression type. So there's basically 4 atoms and then a list expression. I have ints, reals, and then one thing of note is that I have to do this so that I can derive eq and partial eq, because otherwise nans are like not good. If I do, is that a thing? Can I just do that? I don't know. Is that a thing? Well, whatever it may be. Oh. Damn, I just realized now how itchy this thing is. It's kind of crazy. Alright, whatever. Let's kill this. I don't care about that. But there is a basic alias function, and I guess I should probably walk through some of this code. Also, I'm on this Windows computer and the battery life is just atrocious. So this 2 hours is probably going to amount to like 30 minutes. It's so brutal. But whatever. I can use things like set x to 1. And I can get x. And so that's a basic feature. The issue is that this is own values and I don't have down values. So if I were to do set f, here, let me make this f to 1. I right now just have this check that says that set takes a symbol, and so I return a symbol that just says, okay, we failed in doing that. I'm sort of fine with that for now. You know, I might buy an extension cord just so I can plug into that thing. It's kind of annoying because I'm like taking up the whole park, but it's like, this is such a great place to work that there's an outlet like 30 feet from me, and this guy charges his phone here every day. I think it'd be pretty sick because then I wouldn't have to worry about it. Alright, let's keep going. But so the whole purpose of this language that I'm building was actually to start to study combinators, and I just thought it was so cool that you can basically reduce combinators super simply in Wolfram language, just like this. And so far, this is basically what I've implemented. The issue here is that since I use S expressions, I need some code to translate this big long M expression into S expression, and I have a bunch of this done by hand. But for now, I'm just going to show down in my tests. Actually, if I just do set C rules. So these are the equivalent definitions of the combinator rules. So you can see here, right, there's all of these amazing infix patterns that Wolfram language uses. How do I just make this never, whatever, I don't give a shit. But it has all this amazing stuff, so like x blank desugars to, if I just do x, let's see, how's my, well, I don't know, maybe the resolution's low. I don't know yet. But x blank, if I just do this in full form, I mean, of course, everything just lowers to an S expression in the end. So I don't really have any desugaring syntax or infix syntax. So you really have to write pattern x blank. I guess the main thing of note actually is if we were just to say set p to pattern x blank, or let's say xp. Oh, one thing, if you look closely, you can see that I did implement the parentheses thing, so it does at least help me out a little bit, because S expressions, the parentheses just get totally disgusting. But then at least I implemented match queue, so I can say, list A, B, C to XB, and we get true. And then luckily we can do this even more, where we can say pattern X blank list, and we get true. But if I change this to F, then we get false. So we have a basic pattern matcher that can at least function on the heads. And we can take this further. So if I were to take this expression, this ends up being, this SSK expression ends up being the AND, the combinator form of the AND operator, the Boolean AND. And so it turns out that in here, SK is false and K is true. So it turns out that this is just like a way to do Boolean logic and logic in general. With combinators. And it's super cool because in Boolean logic, you need sort of, to get universality, you sort of need three things. You need zero, you need true, you need false, and then you need NAND. You sort of need three things. But what's interesting about in Boolean logic, you need three things to do everything. Can you implement a unary not with NAND? I'm sure you can. Yeah, you just ignore the second one. What's cool about combinators is you only need two things. S and K combinator. everything else is up to interpretation. So that's what's really cool, is that like if you just happen to think of K applied to S as false and K is true, then you can do everything. And it turns out there's a formulation for integers, and you can do math with them and all that. So let's do an example. So here we're doing and. So we could do set and to S of SK. And then we can do replace repeated, which is this equivalent to / dot in Wolfram. So we are going to replace repeated and of K with our C rules, which are combinator rules. And oh, I must have set X to something. So this is right, because that's actually interesting. We should try that. So if I do X equals 1, and I do this, but if I do pattern X, so it's because if we look at the attributes of pattern, we're going to see that it's hold first. Yeah, so I was right. And let me zoom in for everyone. How do I do that? Okay, so we can see it's hold first. So we need to, so the problem, and I'll get to the main evaluation loop. And I'm gonna, I think in future streams, get much more in depth with how the evaluation order works. And I hope this, see, it's already at 1:44. Just dying like crazy. But whatever. I really wish there was an outlet, man. That'd be so cool. But so I've been following this book. What is it called? Wagner. That's way before. Working with held expressions. That's interesting. Okay, but I'm getting ahead of myself. We want to get to section 713. Yeah. Okay, so this is the main evaluation loop. This is basically the sketch that I use to do everything. And I skip all of this stuff about hold. And I don't do any of this attribute stuff yet. And so the purpose actually of today was to try to look into how to do to implementing this. But I think for now, we want to at least get a good description of what's going on. But so the problem here is that this didn't evaluate correctly because X got evaluated and we didn't leave it as is. And so that's obviously an issue. I want to look quickly at the docs for clear and see how they differ from clear all. Clear does not clear attributes, defaults, options, or messages. Okay, so this does everything. Damn, this bug bite sucks. Okay, so we should so I guess this is a good intro to how we might implement a new internal function. And you can see here that this is pretty cringe, and I'll probably have to just completely redo it. But I don't know. I mean, when we get to down values and sub values after we do the attribute system, we'll have to reevaluate how this should actually work. But right now it gets me far enough with reducing combinators that I'm like pretty happy with it actually. But so let's just make a basic clear function. And I think clear, see, oh, yeah, well, I guess one other thing to note that I don't have is the only blank that I have is blank. I don't have blank, null, sequence, or anything implemented. So that will have to, so for now, I'm just going to make clear, take a single symbol. So, so right now, just basically, I'm going to copy this over, format it. I'm going to say string, we want to say it takes an expression, so we actually want to give it this thing. So what happens? What does clear return? Does clear just return? What does it return? Okay, we're still live. That's pretty cool. Clear returns probably null. So wait, let's just test something out. Oops. Yeah. Yeah, we can say if let some te down equals none. Can I just do that? Else we didn't do anything, and then we just return sim num. No. Consider changing this bindings type to be pointer intermediate. Can I do that? Oh wait, I think I have to do. I think this is I have to do that. Okay, so now if I start the thing over, and then I do set x1, and then I do clear x. Yeah, that's not gonna work because interesting. The other issue with this is that there's no place to go to the bathroom. Okay, so the problem with this is that once we've already hit this, we've already evaluated all the arguments. So this is just not gonna work. Okay, so that was a good little thing to look at. Okay. This crashed the program, I think. Yeah. What happens if I do that here? Now we're just making it a little bit more robust. Uh, Right, so now.
And then they were fishing here all day and then buying a boat.
I guess I could say x equals this. Damn, I don't know what the hell's up with that. I don't know what's up with that. Okay. So now we should be able to just do this, and we get a little message, and we get a fail. And I could actually do set x equal to this, and x has failed. Now, we need clear, but alright, before I go, for the time being, let's just do this set C rules thing, set and. Okay, then what we want to do is replace repeated and k of C rules, we get k. Now if we change this to s of k, we get sk. Then if we change this to sk, we also get sk. And then if we change this for our last case to k, we get sk. So here we have successfully reduced the combinator for and in all possible cases of the truth table. So I think that's fuck, I keep banging my shin on this metal bar under this table. It makes no sense. Why is that bar there? Who's gonna crush the table horizontally like that? Okay, whatever. So here I have some pseudocode that corresponds to this, and I guess one issue is, okay, so attributes needs to come first. That's first and foremost. So if we were to just think about how to do an attribute system, I mean, it's kind of interesting, right? Because it seems like we need down values before we have attributes, but I could just manually put them into my table for down values of attributes. This is how I plan to implement it, is that attributes that I just search the whole list for a matching one. It seems like internally attribute system is not implemented as down values of the attribute head, but I don't know. Anyways, I gotta pee. I'll be back, I think.